So here is the start of Chapter 4, and Chapter 4 focuses solely on polynomials. Okay, which you have seen polynomials before, but we're going to just look at all types of polynomials. We need to know what they look like, how they're supposed to be written. There's some definitions that go alongside with them. Today is really not very mathy. We're not going to be multiplying or dividing or adding. What we are going to focus on is being able to look at a polynomial and classify it. You're going to be able to classify it, look at the end behavior, and then evaluate. We're going to do it using our calculator. So here is an example of a polynomial in function notation because it has the f of x. F of x equals negative 2x to the 5th plus x to the 4th minus 3x to the 3rd plus 2x squared minus 7x plus 9. That is a polynomial. It's long, isn't it? A polynomial is a long string of terms being added and subtracted. If we look at this, how many terms are there? 6 terms. This polynomial has 6 terms. Okay? Some polynomials are nice and short. Some of them can be really long. So we'll see some that are tiny, some that are huge. This is a pretty big polynomial. Okay, so 2 things you need to know about polynomials, and they should be automatic. The first is standard form. Okay, just like a quadratic, x squared plus x plus 1, it's just a polynomial. It's a special one. It's called a quadratic, but it's just a polynomial. Standard form is when the exponents are from largest to smallest. So if we look at this polynomial, our exponents, 5, 4, 3, 2, this is a 1, and the 9 has 0. This is in standard form because our exponents, our terms, are listed by their exponent. It does not matter what the number is out front. Doesn't matter if this is negative, a big number, a little number. We only look at the exponents when we write a polynomial in standard form. So we always want to write polynomials in standard form because it helps us do things with them for the next month. It helps us add them, it helps us multiply them, and divide them. Okay, so standard form, largest to smallest. You always want to write your answers or rewrite your questions in standard form. Largest exponent all the way down to smallest. Now, it's possible they're not all there. Like if you were missing the x to the 3rd, you would just keep going, largest to smallest. Standard form. Okay, the last thing that we need to know about polynomials, and it needs to be automatic, is this word called the degree. The degree of a polynomial is whatever the value of the largest exponent is. So in this problem, the largest exponent is 5, right? That's the largest exponent in the entire polynomial. So we would say this polynomial is degree 5. Okay? The degree is whatever the largest exponent is. Now, if your polynomial is written in standard form, that first number, that first exponent, that's always going to be your degree. It will always be a positive whole number. That's the degree. Do you guys have questions about standard form and degree? Again, today's a lot of just like vocab and little tiny things we need to know about polynomials for the rest of the chapter. Are we good? Okay, so standard form, largest to smallest, that's how we write them. The degree is our largest exponent. In this case, it was 5. Okay, next. Okay. What dictates a polynomial versus what is not a polynomial? Now, just because we put a bunch of things added and subtracted together does not necessarily mean it's automatically going to be a polynomial. Okay, so there are 2 rules. The first one is about the coefficients. So if you remember the word coefficients, although it's been a long Christmas break, coefficients are the numbers that are in front of the x's. So if we look at our x's, any number that's in front, so like this 1/2, this -3, negative 0.5. Those numbers that are in front of the x's are called coefficients. And the coefficients have to be real numbers. Okay? Real numbers. Now, real numbers, that does not mean it has to be a nice, pretty number. It just has to be real. So you can't have imaginary numbers. You can't have irrational numbers or unreal numbers. Okay? So examples of some real numbers might be like 1/4, 25.3, 7, -2. Okay? Those are all real numbers. Okay? They're not necessarily perfect whole numbers. Okay? What is not a real number? We call them irrational in math. That might be something like pi or e or the square root of 3. Okay, those are irrational. I forgot the AL. Irrational. If you have any irrational numbers in what looks like a polynomial, it's not a polynomial. So that's the first rule. And all the numbers in front of your x's are called coefficients. They have to be real numbers.
Is that an A or an E?
It's an E. E is like pi. We'll actually learn about E later in the year. Second, the exponents, all of the exponents must be whole numbers, okay? So your exponents do have to be whole numbers, and whole numbers are numbers that are 0 or bigger, not negative, no negative numbers. We call these, the whole numbers are your counting numbers, the numbers you'd count by, 1, 2, 3, 4, 5, 6, 7, 8, okay? You can't have fractions, you can't have decimals, you can't have negative numbers, you most definitely can't have irrational numbers. So your exponents must be whole numbers. So if both of these things are true, all your coefficients are real nice numbers, no unreal numbers, and all of your exponents are the numbers you count by, then it's a polynomial. Okay, so for 1, 2, 3, and 4, what we are going to do is we are going to write them in standard form. So we're going to have to rearrange them. And then we are going to determine if it is a polynomial or not. We'll also write down its degree.
What are those things that where it's simple?
Oh, this? These?
Yeah.
These are just examples of like what numbers would make a polynomial not a polynomial. A pi, e, square root of 3. Those are just examples of not real. Those are unreal numbers. They're not real numbers. They're called irrational. Alright, I'm going to scroll down a little bit. I'm probably going to make this a little bigger for me. Okay, so we're going to write each of these first in standard form before we do anything else. Okay, so if I look at number 1, is it in standard form? No. Well, remember, what does it mean to be in standard form? Exponents are from largest to smallest. And what is our largest exponent in number 1? 4. So that term needs to go first. Now, I probably should have put some colored pencils out today because it is good to kind of highlight each of your terms. Here's a term, 1/2 x squared. This is a term, negative 3x to the 4th. And negative 7 is also a term. So this is a 3-term polynomial. Now, the first thing we're going to do is we're just going to put our terms in order from largest to smallest exponent. That's standard form. So f of x equals, which one's first? Largest exponent is 4, so negative 3x to the 4th. And see how that negative comes with? Make sure you bring whatever sign is in front with it if you're moving it. The next biggest exponent is this 2. This is positive, so plus 1/2 x squared. And then the negative 7 doesn't have any exponents, so that's at the end. This is in standard form. Our exponents go from biggest to smallest. Okay? Once it's in standard form, it's really easy to figure out its degree and determine if it's a polynomial. So is number 1 a polynomial? So remember, our two rules are, look at your coefficients, -3, 1/2, and -7. Are those all real numbers? Yeah, they're all real numbers. There's no weird imaginaries or e's or pi's or square roots. So those are all real numbers. That's good. Are our exponents, the 4 and 2, are those whole numbers? Those are numbers you would, if you were counting the number of your fingers, you would say 2 and 4. So that's all good. This is a polynomial. Right, so this is a polynomial. Okay, if we look at the first term, I'll do it in pink. -3x to the 4th. What is the degree of this polynomial? 4. The largest exponent is 4, so this is a degree 4. Degree 4. Or a 4th degree polynomial. Okay. When you look at number 2, just looking at it, what's the biggest issue you see? Look at what's one of our exponents? Are you allowed to have any negative exponents? No, you're only allowed to have counting numbers, 0, 1, 2, 3, 4. -1, that's a negative number. That's not a whole number. So number 2 is not a polynomial. It's not a polynomial. We don't even have to bother putting it in standard form and writing down its degree. It's not a polynomial. If we look at number 3, check your exponents. What are our two exponents? 3 and x. Right? Isn't one of them x? Is that a whole number? So number 3 is not a polynomial. Okay, last but not least, number 4. Our exponents are 1 and 2. That's fine. Those are whole numbers. But if we look at our coefficients, the number in front, one of our coefficients is pi. So right here, this is a no-no. Pi is not a real number. Negative square root of 2, that's irrational. So this breaks that first rule. Huh?
But there's no negative in there.
The exponents are fine. 2 and a 1, those are totally...
There's no negative.
Oh, it's negative square root of 2.
Oh.
It's on the outside.
Yep. That makes more sense.
Yep. So this also is not a polynomial. Okay. So we got standard form, largest to smallest exponent. We got degree is the largest exponent. Now here, number 1 was our only polynomial, and we reordered it and wrote down our degree. Number 2 had a negative exponent. Number 3 had a variable exponent. That's not allowed either. And number 4, we had 2 coefficients that were irrational. They're not real numbers. So 2, 3, and 4 all failed the polynomial test. Okay, questions about standard form or degree? Or it's good? Good. Okay. Alright, I think this is the second to last thing. Okay, so, just like in biology you classify plants or classify human body parts or whatever you're doing, in math, polynomials can be classified by what they look like. Okay, there's 2 ways to classify polynomials. You can classify them by the number of terms, and you can classify them by their degree. So polynomials that have one term, two terms, or three terms have a special name. They have a special name. If a polynomial only has one term, one single term, we call that a monomial. That's its special name. 4x squared is technically a polynomial. It's just a teeny tiny baby. It only has one term. We can call that a specific type of polynomial. Its specific type is called a monomial. Mono means one in Latin. Okay? Monomial means one term. Same with this, negative 5xy to the third. Even though it has two variables, it's one term. They're all touching. This polynomial is called a monomial. It has one term. Okay? A two-term polynomial is called a binomial. Because again, bi in Latin means two.
And tri means.
And tri means. That's why we call a bicycle and a tricycle a tricycle. Okay, so a binomial, again, is the fancy name for two-term polynomial. In these two examples, we have two terms. Negative 5x to the 6th and negative 4x are two terms. It's a binomial. Same with 12x to the 3rd and 5x to the 8th. Two terms. Binomial. Okay, I know this is getting repetitive. Monomial 1. Binomial 2. Which means trinomial is 3, like a tricycle has 3 wheels. We have one term, two terms, three terms. If a polynomial has exactly 3 terms, it is called a trinomial. Like a special type of a polynomial. Likewise, this other example, 4x to the 4th, 12x, and negative 3, that's 3 terms trinomial. Now, those are the only 3 special names. No, a 4-term polynomial is not called a quadnomial. And a 5-term is not a pentanomial.
I thought Quinn was
Is it Quinn?
5.
It is Quinn, yeah. The only 3 that have special classifications are 1-term, 2-term, and 3rd-term. Anything after this is just called a polynomial. If I showed you a polynomial with 23 terms, you would just say, hey, Tokar, look at this 23-term polynomial. It doesn't have a special name. These are the only 3 special ones you need to know and how to classify. 1-term, 2-term, 3-term. Monomial, binomial, trinomial. The second way to classify is based on the largest exponent, the degree. So we can also classify by the degree. Okay? So if you have a polynomial and you look at the largest exponent, it has special names. Okay, so the first one is what happened if it's degree 0. It has no exponent. We call that a constant. Here's an example of what that might look like. I'll give you 2. F of x equals 6. Or f of x equals negative 2. Do those have an exponent? No. Do they have a variable? No. No variable, no exponent. We call those polynomials constants. These are technically 1-term polynomials, monomials. They don't have a variable, they don't have an exponent. We call that a constant. Okay, the next one. If your polynomial is degree 1, which means the largest exponent is 1, it is called a linear function. That should look familiar from Algebra 1. This might be f of x equals 3x, or f of x equals negative 2x minus 5. In both of these examples, look, monomial, binomial, one term, two term. Both of those, the largest exponent is 1. Okay? When you have a variable with no exponent by it, there's really a 1 there. We just don't write it. It's invisible. These are both called linear polynomials. The first example is monomial. The second example is a binomial. Okay, degree 2. We know these, and we've used this word. It's called a quadratic. If you have a polynomial with the largest exponent of 2, x squared, x to the power of 2, that is called a quadratic. Quadratic. We'll do an example. F of x equals 3x squared minus 2x plus 7. There's an example of a quadratic because the largest exponent is 2. This has degree 2. It's called a quadratic. And in that example, how many terms are there? So it's what if we classify by how many terms, it would be a trinomial. 3 terms, 3 wheels, tricycle, trinomial. Okie dokie. Does anyone know what we call a degree 3? It is called a cubic. That comes from how you find the volume of a cube. A cube has all three, length, width, and height, all the same exact length. And the formula for the volume of a cube is side to the third power, which is why we call it a cubic. Because x to the third is the formula for finding the volume of a cube. So we call it cubic. Okay? A cubic function means its largest exponent is 3. So let's make an example. 1x to the third minus 2x squared plus 7x minus 5. There's a cubic function. This specific cubic function has 1, 2, 3, 4 terms. So we just call it 4-term polynomial. It doesn't have a special secret name. It's a cubic 4-term polynomial. Anyone know what a 4 term is called? Or degree 4? Anyone know? It's the same way the quarter got its name. It is called a quartic. Quartic polynomial. This is the last one you need to know. Anything above this you can just call 5th degree, 6th degree, 7th degree, 8th degree. There are names for all of them. There's names for all of it forever. They have a name for it. But you only need to know 0, 1, 2, 3, and 4. Constant, linear, quadratic, 3rd degree, cubic, 4th degree, quartic. Here's a good example. F of x equals x to the 4 plus 2x to the 3rd minus 3x squared plus x minus 7. Look at that bad boy. There's a quartic function. Again, it's not a quartic because of how many terms it has, It's called a quartic because the largest exponent is 4. So there are two ways to classify polynomials. We just classified by degree, by the largest exponent. Again, this all comes from the exponent. The constant didn't have one. Linear, even though there isn't an exponent written down there, there's really a 1. It's just invisible. There are exponents of 1 there. The quadratic had an exponent of 2. Cubic had an exponent of 3. Quartic had an exponent of 4. Those exponents are how they get their name. When we're classifying by the number of terms, monomial, binomial, and trinomial, that's all based on how many terms they have. It has nothing to do with their exponents, just how many terms are there. So, number of terms by degree. Okay, so those are things we need to know. Alright, last thing for today. We get to use our calculator. Take out your calculator. Unsheath it. You just have one on your desk and you use that. Don't worry about the number. I'm going to pull up my calculator. There it is. Turn it on. I would do your second plus 712. Clear it out. Second plus 712. The last thing we're going to quick review, which you have done before, probably even before Algebra 1, but definitely in Algebra 1, is evaluating a function. So we need to be able to take a polynomial and plug in a number for all of the x. I put an example of how you would do it by hand. So for example, I know it's small here, but you should be able to see it on your paper. F of x equals 2x to the 4th minus 8x squared plus 5x minus 7 when x equals 3. So if we wanted to know what happens to this polynomial when x is 3, if you wanted to do this by hand, you would plug in a 3 everywhere you have an x. There's 3 x's, so they plugged in 3 3's. Okay, and then they figure out what each one is. 3 to the 4th times 2 is 162. 3 squared times 8 is 72. Let's see how they simplified, and eventually they got all the way down to one number. When you plug in 3 into that polynomial, it ends up equaling 98. Okay, that's called evaluating. Plug and shove. It tells you what to plug into your polynomial, and you could do it with mental math in your calculator. We're going to evaluate using our calculator. Okay, so we're going to practice doing that really quick. Okay, so here is the one we're going to try. 2x to the 3rd minus 4x squared plus x. So you're going to go to your y equals, and we're going to plug in our polynomial. Now remember, you only need to plug in everything after the equal sign. So we will plug in all of this. 2x to the power of 3 minus 4x squared plus x. Make sure you got it all in exactly how it looks. So to do a power of anything other than 2, right above the division symbol is what's called the caret. It looks like an upwards arrow. That like goes up to the exponent. After you type it in, you need to click the arrows to come back down. So like here, watch. See how, boom, it brought me up? If I were typing in a number, you'd have to click the arrow over to come back down, or else it'll keep typing up top. Okay. In this example, what does it want us to plug in for x? It wants us to plug in 2. F of 2, look, it's like there's a 2 instead of an x. This means this is the same thing as when x equals 2. We want to know what happens when I plug in 2 for x. Now there's two easy ways to do this. The first way is you could just go to your table by clicking second graph, and you could go look. At x equals 2, it's equals 2. See how 2 goes with 2? If I plug in 2, you get 2. If I plug in 3, you get 21. If you plug in 6, you get 294. You could just go look at your table. Sometimes this might not be a nice whole number, so the other way is good to know too. If I go to my graph, it'll graph my polynomial. If you're curious what that cubic function looks like, that's what it looks like. The second way to do it is if I click trace, I can type in any x value I want. I want to know at 2, so I can just type in 2, and look, it says x equals 2. You click enter, and it tells me it's 2. Both ways work. Okay, so if you want to give yourself some steps for this, we could make a little list of steps. Step 1 would be plug in the polynomial. If you want to write yourself the button, it's called the y equals button. Plug in the polynomial. Okay, now there's two ways you can do it. Okay, so we're going to do like two little separate sets of directions. You could just click the graph button, or you could go to your table, which is second and then graph. Okay, if you go to the graph, which we just did, if you click graph, then all you have to do is then click trace. And then enter your number. Okay, so here if we click trace, I can now plug in anything I want. I could plug in 5 and click enter and it would tell me. I could click trace and I could enter in -3 and click enter. I could click trace, I could even put in a fraction. I could click 1 divided by 4, 1/4. The graph way is nice because you can type in anything you want. If you do it the table way, which is when you click second graph, what's the downside to this? Let's say you want to know when it equals 1/2. Is there a 1/2 in our list? No. Okay, so it's good for whole numbers.
Good morning, Tiger Nation, and Happy New Year. Students, this is the last week of semester 1. On Friday, we will honor exams for periods 6 and 7. We plan to follow the December 23rd exam schedule. Period 6 and 7, and then makeup exams on Friday. And that is the last day of semester 1. On Monday, we celebrate the Martin Luther King holiday. On Tuesday, January 17th, the staff, we have professional development, and so we will see you back on January 18th to start semester 2. I'll send out this information again to you and your families later today. On Wednesday of this week, we have expectation assembly.